Alright, let's say a soda company claims that they have a mean of 12 ounces and a standard deviation of 0.5. And we're going to test out 35 random cans. And X bar is 11.9 of those 35 cans. What is the probability of getting that low or worse? So the mean of X bar is equal to 12. And the sigma of X bar is equal to 0.5 over the square root of 35. Now the two reasons why we know it's normal is because we have 35, which means CLT, and the second thing is that they give us the standard deviation. We don't use the sample. So this turns out to be 0.08. So 11.9 would be right about there. And we want to know what this area is. So we're going to find the z-score. Remember, we're using z because they gave us the standard deviation of the whole thing. So negative 0.1 divided by my answer turns out to be negative 1.18. So the probability that z is less than negative 1.18 equals 0.118, which means that even though it's not great for us, 11.9 gave us the answer of 11.8%, which could be understandable. Let's say instead of 11.9, it was 11.7. So that's even further out. And if we got a standard deviation of 11.7, then the z-score would be negative 3.5. And the probability z is less than negative 3.5 equals 0.0019. Actually 0.00019. And so this means that I'm pretty sure that they're cheating us. So the basic about this is, does the result seem reasonable or does the result seem too bad? And so in this section we're also going to talk about the population and the hypotheses. So in this population it would be all cans of soda from the company. Mu equals the average amount in the cans. And so my initial hypothesis or my null hypothesis is that they're telling the truth. My alternate hypothesis is that they are cheating me by not giving me enough pop. If they're giving me more pop, hey, that's great. If they're giving me less pop, that's what I'm trying to figure out. Alright, so let's say the AP test last year had an average score of 60 points last year, and we want to see if this year's is going to be scored any different by scoring 150 tests and seeing how different it is from last year. So the population would be this year's AP test. The parameter, which is mu, equals the average number of points. So my initial hypothesis is always going to be mu equals some number. So in this case, if we want to check to see if it's the same as last year, mu is equal to 60. Now, I don't know if the new score is going to be 60 or higher than 60 or lower than 60. So since we don't know whether it's higher or lower, we're just going to start with not equal to 60. And so that's how we would write it. And this is referred to as a two-tailed because it's not equaled, and the one on the last example would be one-tailed. And so this is our first look at hypothesis testing.